Let's study this week. Case 13 in the Dynamic Replacement Manual. Line segment replacement and coloring. In this case, I should have been 4 years ago. It should be a tutorial from 19 years ago. I didn't record the vocal commentary at that time. Then I posted it online. Then I felt it is necessary to include it in our replacement manual. Then today we will learn its specific production. Then I was using the default renderer. Then I re-rendered it with Octane. From material production to this. This dynamic is still the same as the original one, but I am using his materials and these. Made some adjustments to him. Then use the default renderer. He is very slow, like 3 or 4 minutes per frame. I now use OC to render this effect. Only 20 seconds per frame. 1920 times 1080. Okay, this is the rendering effect of our final case. Its main selling point. In other words, it mainly presents it's the motion on the line segment. Then there's the dynamics of these light effects. Okay, let's take a look at our project files. Okay, this is our project. That is to say, we use the matrix. Type is radiation. Then we use the tracking object of the motion graphics. Then take this matrix and connect it. Then the type is B-spline. Then point interpolation method uses natural. Then use this clone. Clone it as a line segment. Next, what about cloning? Add 2 colors to it. I added a random effector above the matrix. Randomly, its XYZ is its movement in several axes. Let it do a displacement there. This is the motion on the line segment, is through random here. Then inside the random effector. Then put it in random pattern using stream. Then animation rate 30. Scale 50 and then match a domain. Use a sphere domain to start with the largest. Then slowly shrink the end and minimize it. Something like this comes from nothing, and then to nothing. Such a dynamic process. Okay, this is our replacement dynamic. Then I build on his foundation, add another coloring. Use easy custom colors. I use a green one here. Then use a domain. Inside the domain is the shading domain. A noise is used in the shading field, where he moves after the noise. Then his global scaling is 0.1. It's relatively small. Then use a multiply here. Multiply, it's because he doesn't use this here. These are all too real for him, so I use gradient here. The gradient is this U. Then he has a cool U here. Just let him have some changes and transitions like this. There's an angle here. The movement above should be like this, where it turns. So this noise is rotating there. So it appears. This is the brightness we have here. It will look like it is moving there. Okay. Then we added another blue color here. Same as custom colors. Then the same is true in the domain. Also use this contraction. Domain 2. Here you need to use a gradient to limit its range. Because I want it to be within this range. This one is the same as the previous one. There is no animation here from this angle. This one doesn't have K animation. He won't move this himself. Then use gradient to limit its range. The general production idea is like this. Then we use a random. Randomi. In the future, we will also use Twilio. Use the object inside the deformulator. Let him move up and down here like this. The time effector allows it to rotate on the H-axis. Then the deformer is an object. That is to say, our project file. Its overall production ideas are these. Okay, let's make it again. Let's create a new project. We use a matrix. Add a matrix. Matrix uses radiation. Let's change its quantity to 30. Then we continue to use motion graphics. Tracking object. To track objects we use connections. All object types use B-splines. Use the same difference. Then we hide this matrix. Select this matrix. Let's add a random effector to it. Random effects. Default parameters. Then we change its intensity to smaller. Don't be so strong. For example, 20. Here we change it to random flow. Change the speed to 20. Change the zoom to 50. And what about his current line? There is no closure here. We choose who to track. Here is a closed spline. We check. Let's play the timeline and take a look. Okay, he'll start exercising like this now. Create a new blank. You have to leave a blank space to put it in. Otherwise, if he clones him, he won't be able to identify him. Okay, let's select the matrix. Hold Alt key to clone. Then we change the mode to linear. Change position Y to 0. We changed the quantity to 40. Then zoom. Let's change it to 102. Control plus Enter. We change the radius of the matrix to 10. At this time, he is the movement of every thread. He is all different. Let's create a new ball. He may be too young now. Let's change this radius to 100. Change it to 100. We're going to refresh it. OK. Then we change this amount to a higher level. Change the quantity to 200. OK, our spline is now created. Then we need to add a random domain to this. We use a sphere domain. Let's make an animation for him. Change the time to 200 frames. Let's get to 50 frames. Change its value to a larger value. For example, 500. Hold down the Control key and click on it. Record animation frame 0 here. Let's change it to 0. Press Control, click here. Good. 170 looks like. Let him shrink a little more if appropriate. When we hit 200, we change it to 0 again. Well, let's play it. He started by making something from scratch. Then slowly shrink. Eventually it disappears. This is his dynamic part. OK. We then give him a coloring. First select clone. Let's change this color to black in the transformation. It is now a black line. Take this sphere domain and close it. Show selected clone. Add simple effects. Remove the position. Don't check. Color mode. We use custom colors. We use light green. Add a color domain layer to it inside the domain. Then first add a noise to it in the coloring. Change its value to 1. Change animation speed to 1. Let's play it and take a look. Don't use textures. We're going to use UV2 using this mode. At this time, you can adjust the contrast. All of this is fine. OK, now he has a rough color. You can give him some fine-tuning. OK, let's select the shading domain layer. Let's click on this box. OK, let's add a gradient to it. Let's take this gradient. Change its color distribution, for example. For example, let's add a flow to it now. Use multiply mode. OK, at this time we just added a lot of details. It will be a lot more monotonous. Let's add another one here. This gradient, this kind of thing inside. He will be richer, but he didn't move here. We can add a folder to him. Select folder. Give him multiply mode. Throw the gradient in. There's an effector here. Let's give him a transformation. Add transformation. We can adjust the angle of it. It feels like he is moving here. You can make an animation record for him. But the record must be clicked here. Click here for shader properties. We go to frame 0. Let's click here. Then go to 200. Let's change it to 45. Play it again. OK. At this time, he will have many levels. OK. This is the green part. Ours is called green. Let's give him a blue color here. Clone, let's throw this blue in. Let's change this color to blue. OK, let's first put the shading field to here. Go in here. Let's delete this animation first. Then we change the noise seed. Then this gradient can also be adjusted. Don't be exactly the same. It's different from him. Both are the same. Seed scaling. Good. Then we need to restrict the area to it. Right, add a shader gradient. Let's pull out this gradient. Use multiply. Let's limit this blue color here. Well, we already have the blue part. Add another brightness contrast here. He doesn't have enough contrast here. OK. OK, this is our color part. I actually use K for the gradient. This one is good. For example, to 45. Let's click on this gradient. Then at frame 0 we let it. Make a record. OK, here's like this. There will be a better transition. We add an entity called entity to him. Change our entity to 0. Here we use -190. Let's click on this domain first. Then we change the visibility to 100. At this time he will disappear. The starting point here is the same. We will record here at 25 o'clock. Then at frame 0 we change it to 100. Just click here again. At this time, he came from nothing. Then it spread here. Then disappear. OK. OK, this is the color of our dynamic and line segments. OK. OK, let's move on to this little ball. Let's move its position. It is a size radius of 100. We also change the y-axis to 100. Let's add random effects to him. The random effect can be used as a deformer. We use objects. Let's ask him to make a movement on the y-axis. For example, 150. Minimum is 0. Random mode change to drifting. This place will vibrate up and down. Let's change this speed to 25. Change the zoom to 515. 150. It's going up and down right there. The random effect can be used as a deformer. Same, we can make the object move there as a whole. OK, let's add a time effector to it. Better to change it to object. It will turn. The speed of rotation. You can pass the angle of rotation here, or maybe it's the intensity of the effects here. Control well through these two. This is our model part. Then we will create a new plane for him. Let's zoom in on the plane. Change the number of paragraphs in this paragraph. This is not a big problem. We can do this without moving this clone. But you are in random Y. Here it's minimum value. We don't want negative numbers. We only need 0, 100. Then we can change this intensity. Then the y-axis can be a little more. X20 is 20. Then we change the color of the plane. Change to darker color. Then we create a new folder. Throw in the clones. This is called a fragment. This is called geo. Create a new semicircle here. This uses pipe outer radius. Internal radius. Outer radius. Then its height. Highly segmented. Rotated segments. Then change the slice height to 120. Change position Y to 60. Then we add a chamfer to this pipe. Add a segment. OK. OK, this is our model part. Then you render this line segment. Just add the OC tag to him. OC label hair. Turn on rendering hair. If you render directly in Octane, it's impossible to color your color. Give him this material ball. Here we select this tracking object. We add a scan and create a new polygon. Multilateral change to 0.5. Let's change the side to 8. Then throw it over. Change to 0.2. OK, he can recognize it now. It must be materialized in order to be recognized. Create a new one that is also a reflective material ball. Change to dark black. Roughness is high. Not so much reflection intensity. Then his current line segment is too reflective. We take the reflection value of this line segment. Give it a high roughness first. OK, this is the first step, because we give him a glowing treatment. To emit light, we use a reflective shader here. He can't use light here. Let's change this material type to universal. Here we pull a self-illuminating one. And then we're going to do a blend on it. We use A. The gradient of OC turns black and white into black and white. Then we use a multiplication. Make this black and white. Multiply a color with its original color. It will only act on these areas of ours. These other black areas will not be affected. Let's change it to 20. Give me this color. Let's see what happens. It will illuminate this everywhere. This is not what we want. What about after our mixing? It will have richer levels here. And we can also make some adjustments to him here. Let's give this strip again. Let's add a glass material ball to it. The glass material gives this to the pipe. 0.1 good. We will also have to deal with this light next. Perform a texture processing. We use October gradient. Use a linear copy of both. Adjust its angle to 90. Then multiply it by. Multiply. OK, this is the light map. We then load it in using an HDR. OK, this is our HDR. Let's turn it down a little bit. Change it to 0.2 and then deal with the small ball. Create a material. We use a synthetic material. Composite material. Throw this to the ball. OK, let's create a new material ball by synthesizing the material. It's white. And then give it a little bit of roughness. Then on his L roughness we load an image. Add a scratch material to him. Then use arrange. Then connect to roughness. We change the minimum to 0.2. Change the sampling value to high 1500. Change GI to 10. Lock on noise and adaptive sampling. Good for us. Then use a black shader ball. Create a new material. Let's change this material to darker. Then his roughness increased. Then we need to create a noise for him. Octane O noise. Add an OC gradient. Connect to material mask. Then change it to Veroni. Then increase its contrast. Gamma transform. Let's make it smaller. Then we change this light to 150. Then we turn on the post effects of the camera. Add some glow to him. Let's change the light angle to 90. This kind of horizontal stretching. Then the effect color channel separation. Then our depth camera. Change the type to global. You can do a little bit of work on the ground. We're using an image for the roughness here. Then add a scratch to it. Material. Then use a chaos. Let's connect this. Add a transform. Give this roughness. Then give a range. 0.2. Just like that tile. We can use Octane gradient. Then use a linear. Then we take this gradient. It's connected to this bump. Let's put this white position in the middle. Change to 50. Then change this to 49. Then create a new one and change this to 51. Then change it to black. Okay, let's get stuck in a line. Then we copy the gradient with a control. Then turn it 90 degrees. Then perform an addition add. At this time, there will be a cross effect. Then you need to change this amount to more. Don't be just one. You can use a baking texture. After adding it here, let's use another transformation. We can give it a scaling. It will now form this kind of grid. This grid. 0.1. Okay, this is the final result of our case. Let's take the camera's reference line and turn it on. Put this ground can put it. Zoom it. That is to say, we use the clone of the line segment and then color it. Then perform a physical rendering on it. This is our overall effect today. Follow the production idea. This is Debao Dynamic Design. Thank you for watching. See you in the next class. Bye.